Right, now we go to parallel circuit. I think the most important thing to remember is for two or more resistors in parallel, the potential difference across them, let's say these are points X and Y, remains the same. Okay, so I would do the shortcut first, or rather the easier method, so that I will follow by the longer way. Right. So if the question does not restrict our approach or steps, I would rather take I2 to be equal to V over R. So I2, which is this branch of the current, will be equal to 1.5 divided by 2, which is 0.71 ampere. And I3 will be equal to V over R3. Remember the same potential drop or the same potential difference, which is 1.5 over 3 ohms, that is 0.50 ampere. In many MCQ questions, you'll be given things like, current I1 will be equal to current I4, because obviously whether it is I1 or I4, it is equal to I3 plus I2, or I2 plus I3. Voltmeter wise, the reading of voltmeter V1 will be equal to the reading of voltmeter V2, and it is also equal to the reading of voltmeter V3, right? So again, if I removed or ignore all the ammeters and voltmeters, the circuit diagram looks much simpler, right? And I would like everyone to appreciate that circuit-wise, these two circuits are exactly the same, because this point is X, that point is Y, and this is X, and that is Y. The potential difference of XY remains equal to the EMF of the cell, which is 1.5 volts in all instances. Okay, so I4 equals to I1 equals to I2 plus I3 is equal to 0.75 plus 0.5 equals to 1.25 ampere. And if we are interested in the total resistance of the circuit, we can then use 1.5 divided by 1.25 divided by 3, divided by 5, which is 6 over 5, which is 1.2 ohms. So if we are not restricted by the question, we can find the branch currents and then only reach the total resistance. Now, another method is the conventional way. If the question so demands that you find the total resistance of the circuit, then we have no choice but to work that out first, right? Which gives also R equals to 1.2 ohms. then a little difficulty will arise. So let me draw just this part, yeah? Sorry about that. Just take that as a resistor, not a fuse, yeah? Take that as a resistor. And if you are able to appreciate this one, this is point X, this is point Y, and as usual, the potential difference across here is the whole EMF. So this is I2, and that is 2 ohm. This is I3, and that is 3 ohm. And let's call that I1, yeah? So first, we may find out I1 by using V over R. So V is 1.5, R is 1.2, which gives me 1.25 ampere. So I get the total current first. But I2 plus I3 equals to I1. So I2 plus I3 equals to 1.25 ampere. Right? So from the definition of potential difference, I2, I2 times 2 must be equal to I3 times 3. Right? So 2I2 equals to 3I3. Which is nothing but to say that the currents in the branches are in inverse proportion, are in inverse proportion to the resistances. Alright? So solving 1 and 2, okay, I'll leave that as an exercise. You would be able to come back to the same thing, which is I2 equals to 0.75 ampere and I3 equals to 0.50 ampere. It is particularly important for A-level and STPM students to be able to appreciate both the methods, especially method number 1. Right. So I would like now to share with you, and I hope you can try on your own, the sums which I will give the solution or solve them in another installment, in the forthcoming installment. Let's say very often in the A level or the STPM, and we are just given a question like this, sometimes in the MCQ. Alright? And the thing is, we'll put a 2 ohm there, we'll put let's say 3 ohm there, and I put a 6 ohm there. Alright? And I can just do something like this. I'll just say that, a 1.2 ampere current goes to there. My question is, what is I? Right? So that will be exercise number 1. Exercise number 2. Let's add something. And how about this? Right? So be very careful not to be caught. Right? I think not so much for the IG and SPM, but you could always try. Let's say I put a 1 ohm here, a 2 ohm here, and a 3 ohm here, and I tell you that the EMF across this is 12 volts. Find me the current I1, I2, I3, and the current I4. And one last question for rounding up today's lesson. I will give you a circuit, but this time I will have a single resistor, then it is in series with a pair of resistors in parallel. Alright, very common looking question, right? And I think it is about the standard required of IG as well as the AS level of A level. Right. Let's say I put in some numbers. This is 9 volts, this is 3 ohm, this is 6 ohm, and that just become 1 ohm. Alright? And the question is, find the current through each resistor. Ignore, of course, internal resistance of the cell or battery. Yeah? I would like to say something here. If you can understand and apply this question and truly, appreciate what is going on, I think you have understood this part of the current electricity theory, and calculations quite well. Okay, till I see you next time when I will discuss the solution of all these. Alright, bye bye.